Third-year student majoring in mechatronics engineering. Today, I'll be discussing the topic of controlling Dynamixel with STM32. The presentation will cover overview, system configuration, Dynamixel protocol, Dynamixel, Dynamixel and STM32 setup, and will conclude with a short demonstration video. Dynamixel is a brand of robotic actuators developed by Robotics designed for integration into various robotic systems. Each Dynamixel actuator can be controlled by sending data packets over a shared communication bus. Multiple Dynamixel units can be connected in a daisy chain configuration using the available ports on each unit, requiring only a single cable for both control and power. Dynamixel supports RS-485 and TTL networks, utilizing asynchronous half-duplex communication. It is also compatible with a wide range of development environments. Let me first explain the hardware configuration of Dynamixel. The model I used is the AEX12A, although there are many other types of Dynamixel actuators available. This model supports a maximum communication speed of 1 Mbps and has a resolution of 0.29 degrees. It can operate in two modes, joint mode and wheel mode. In joint mode, the rotation angle is limited to 0 to 300 degrees. The stall torque of the AX12A is 1.5 newton-meter, which is about 0.5 times stronger than the widely used MG996R servo motor. The operating voltage ranges from 9 to 12 volts, with 11.1 volt being the most commonly used. It utilizes half-duplex TTL level serial communication for data transmission. Next, I will explain the control table of Dynamixel. Each motor is equipped with an EEPROM and RAM. The EEPROM section is non-volatile memory, meaning that the values remain stored even when the power is turned off. In contrast, the RAM section is volatile memory, so it resets to the initial values when the power is turned off. The highlight section is the slide, indicate the values are mainly used for controlling Dynamixel. To control Dynamixel with STM, a communication conversion circuit is required. This is because the half-duplex UART signal from the STM needs to be converted to the half-duplex signal used by Dynamixel. Additionally, the logic level of STM is 3.3 volt, while the logic level of Dynamixel is 5 volt, so level shifter was used. The left photo on the slide shows the conversion circuit diagram, and the right photo shows the solar version on PCB. Next, I will explain the Dynamixel protocol. The Dynamixel protocol is a data transmission standard provided by Lotus, designed for controlling and communicating with Dynamixel series. Using this protocol, users can send command of Dynamixel motors and receive various status information for them. The basic structure of protocol involves the user sending an instruction packet to Dynamixel and the Dynamixel responding with a return packet. All packets are transmitted by 8-bit unit. The structure of an instruction packet is divided into 6 main parts. The first part is a header. The header consists of 2 bytes and signals the start of packet transmission. The second part is the packet ID. Each Dynamixel has unique ID, which is used to select the target Dynamixel for the command. The third part is the length field, which defines the length of following data calculated as the parameter, length plus 2. The fourth part is a command field, which defines the action of Dynamixel. You can refer to command field example on the right for clarification. The fifth part is a parameter field, where the content and length vary based on the instruction command used. For example, if the instruction is write and you want to input the value 500, since in hex 1F4 is 8 bits, it is split into high 8 bits and low 8 bits, assigned to the parameter 1 and parameter 2 respectively. The last part is the checksum. The checksum is used to check if the packet has been damaged during transmission and is calculated by summing all preceding bits and taking the complements. The structure of return packet is similar to that the instruction packet. The key difference is that instruction bit is replaced by an error bit. The error bit indicates if there is an issue with the operation of Dynamixel. The specific meaning of each error bit can be found in the table on the right. Next, I will explain the setup process for Dynamixel and STM board. Let's start with the Dynamixel configuration. Connect the PC, the U2D to power hub board, and the Dynamixel. The U2D to power hub board is the combined module that provides power to the Dynamixel and enable communication between the PC and the Dynamixel. The software I use Dynamixel Wizard. In Dynamixel Wizard, you can configure the protocol, port, search baud rate, and ID range, then click the scan button to detect the connected Dynamixel units. The screen on the right shows the result after the scan is completed. Here you can easily adjust from EEPROM settings as previously described, and also modify the RAM setting to test if the motor is functioning properly. Now I will explain the STM board configuration. For basic operation, you need to configure one GPIO and one UART. The GPIO configuration is necessary because we are using a half duplex communication method, which requires a signal to switch between TX and RX in UART communication. The UART is configured as UART2. Finally, I will conclude the presentation with a short demonstration video of system in action. After that, I will proceed to the Q&A session. Thank you.
유튜브에서 한 3주 준비하면 할 수 있을 것 같아. 3주? 그때 내가 하루 준비했어.
네.